Now moving on to Lab 1, variables and data types. Variables are one of the fundamental building blocks of programming. A variable is a symbolic name that refers to a memory location where data is stored. It allows programmers to store, retrieve, and manipulate values efficiently. Assigning values to variables. The syntax for assigning values to variables is this: the variable name and then the value. In cybersecurity, analyzing and processing textual data is crucial for detecting threats, passing logs, and extracting useful information from network traffic. Python's string slicing and indexing features enable efficient manipulation of text data, simplifying the automation of security tasks and extraction of relevant information. In Python, modules are files that contain reusable code that can be imported and used in your programs. Python provides several built-in modules that allow you to interact with operating system, some of which are OS, sys, random, time, string. And we'll have example. For the OS module provides a way to interact with the operating system. It allows you to work with files, directories, and other system-level operations.
Python allows cybersecurity analysts to automate routine tasks, detect and respond to threats faster, and ensure better analysis of logs, networks, and systems. So here is how Python helps in threat detection, response, and analysis. So in threat detection, Python helps to automate scanning and monitoring of networks for vulnerabilities. In response, Python helps to rapidly react to the detected threats using Python scripts for alerts and reports. Then in analysis, process and analyze large volumes of data to identify potential security breaches or anomalies. That's slicing and casting. So the real-world application for slicing and casting here is extracting sensitive information from logs. And this is the use case: extracting personal identifiable information, PII, passing system logs to identify and extract user information, e.g. credit card numbers or user IDs. So the scenario here is, as a penetration tester, I need to automate the extraction of sensitive data from server logs to identify potential information leakage that could compromise the security of the company. So on to the lessons learned. Python's simplicity makes it an effective tool for cybersecurity. Automation can significantly improve response time to threats. Then cybersecurity industry application, SOC analyst, penetration tester, that's automate reconnaissance, then an incident responder, automate evidence collection. Then my future learning path, to explore advanced topics such as machine learning or AI in cybersecurity and advanced network security.
Data types. Now, Python variables and data types help us to store and manage critical security data. So in cybersecurity, we often deal with structured and unstructured data. Now, such as user credentials, things like user credentials, log files, network addresses, and all of them. We use variables to efficiently store and manipulate data, right? And we use different type of variables. Loops help us automate repetitive security tasks such as scanning networks, processing logs, and monitoring system activities. In cybersecurity, automation saves time as it improves efficiency. Now, for loops basically allow us to iterate over a list or logs, checking multiple entries for a security. So Python modules basically expand its capabilities by making it a powerful tool for cybersecurity. So Python includes modules like OS for system commands and sys for system level interactions, and there are third-party modules which are basically libraries such as psutil, like that we use in this use case, and then we basically help monitor network security.
We're going to be going through each topic one after the other as we went through it in the Python module. The first topic is variable and data types. Now in Python, we have various types of variables such as strings, integers, list, floats. And I'm going to be touching up on a couple. But a variable is basically a placeholder identifier that holds the value of something. And we have different types of this. So you can have a string variable. This is usually denoted with inverted. This is usually denoted with apostrophes, and integers is usually numbers or things that have numbers within them. And we have lists as well. So with loops, they are also inbuilt, and they find a way to read through a list of data or read through a bulk of data, and depending on the condition you write within your loop, it does that and fishes what you're looking for out for you. So we have two main essential loops in Python. We have for loops and while loops. For loops basically iterate through IP list to scan multiple endpoint efficiencies. That is one use case for a for loop. It iterates through something and scans it depending on the condition you give it. Now we have functions. So functions in Python, like any other programming language that has functions, a function from the word is something that you declare or write that does a particular thing. So you create a function, call it whatever the function is going to carry out, and within that function you now write the different conditions, you write what you want it to do. And with functions you can have parameters and arguments, so things that you can get and call as the function is rolling.
It allows for automation and scripting. Repetitive tasks like log analysis and vulnerability scanning can be easily automated. Threat detection and analysis. Python helps in writing scripts to detect malware. Penetration testing. Many cybersecurity tools like Scapy and PyTest are built in Python for ethical hacking and security testing. Also, we have rapid prototyping. Then we have some extensive libraries and community support. We print the uppercase files and then we iterate through the uppercase files. So if any file ends with ext, that's ext is here. So .exe, .bat, .vbs. If it ends with any of those, we print threats detected. So here we put some sample files here and we iterate through it. And there, this is the output. It shows the files here, sorted files, and then it shows whether each of them is either safe or is a threat. That's for use case 2 for basic functions. First scenario as using requests to check website security. So we check if a website is running HTTPS. So KPIs include the response time and the HTTPS adoption rate. Here we import the request module here, and we define check HTTPS and URL as a parameter. Then response is request.get URL. And if the response.url is start.
So why Python for cybersecurity? First, for automation need, there is increasing need for automation and scripting in cybersecurity, and Python is just the best option for such. 2, threat management. Python helps in threat detection, response, and analysis workflows. Also, it gives us a boost on how to use Python in our cybersecurity career, outspeed. So what this does is, it's a real-world application of it. It logs security alerts to a file for all these purposes. And the use case is write logged failed login attempts to a log file for later review. So in the industry, when you can do it overnight, then when you wake up in the morning, you go and check, you see a lot of login attempts which has been saved to a file, which input and output can use, which input and output can be used for. And the defense application is this logs failed SSH attempts for auditing. Modules is next. So a defensive application of modules is resolves domains to IPs for threat checking. The use case is the socket module to resolve domain names and check against the block list. And it automates DNS lookups for threat intelligence. So right here we imported this module, which is socket, and we said domain is equals to Google domain, and socket.guest host by name.